Throughout this course, I will be using Linux with my text editor of choice being Kwrite, but you can feel free to use any system and any text editor as long as you can just edit simple text files. And the version of C or the format of C which we will be using for this course will be ANSI C. In part 1, we're going to focus on functions, variables, and operators. So let's create our first file. I'm going to call it Hello C. And the first thing which we have to know about C is that everything in C happens inside of functions. Functions are reusable blocks of code which can both take inputs and return outputs. Every C program has a default function called the main function, which has to be in pretty much every file, and it is the function that's being called by default when you start your program. To define that function, we're going to write int main, and then inside of brackets, int argc, comma, char, double asterisk, argv. After this line of code, we're going to put open and close curly brackets, inside of which is the body of our function. And at the last line of our function, which is just before the closing curly bracket, I will type return 0. Let's take a look at what I have actually done now. First off, I declared a main function called main, but I had to add all of those other things around it. First off is the word int, which stands for integer, before the word main. This is the return type of the function, which means our main function will be returning or outputting a value which will be an integer, and integers are simply full numbers. Inside of those brackets, after the name of our function, I have specified an integer called argc, which is our first input to the function, and in the main function specifically, this argument is the count of how many arguments you passed through the console when starting the program. You don't have to worry about that now, we will cover it in a future episode. The second input to our main function is a character type variable of double pointer argv, which is the actual list of all the inputs from the console. You also don't have to worry about that now. Then inside of the body of our function, I've written return 0 and then a semicolon. Return is a statement which, as the name suggests, returns a value from a function, and since our function is an integer return type, we have to return an integer, and 0 is an integer, so we can return it. Why exactly am I returning 0 and not any other number? And that is because the return value from the main function is actually what tells our program if it was closed successfully or if there was any issues. Return 0 simply means the program has finished successfully and there was no errors on the way. Now that we have our main function, we can try and print hello world to the console. But to do that, we actually have to include a standard library which comes with some commands to allow us to do so. If we want to include such a library, we have to go to the top of the file and type hash include lower than and higher than, in between which we specify the name of the standard library which we want to include. In this case, we want to include stdio.h, which is the standard library that includes a command we will use to print our text to console. So let's go back to our main function, and we have to use a command called printf, inside of which I will put an opening and closing double quote, in between which we can simply input our text, which we want to print to the console. And in our case, it's hello world. In C, you have to remember that after pretty much every command you type, you have to put a semicolon at the end for the program to function properly, because it signifies the end of the line to the compiler. If you look carefully, you can notice that after our main function, we don't actually have a semicolon, and that's because we're using curly brackets to specify the body of the main function, so the semicolon is not needed. If we save our file, we can actually test if it works now. So going back to the console, and now we have to compile our C file into an actual executable program. However, I noticed one mistake I made When I was creating the file, I didn't specify it to be a C file, because to do so, you have to add a .c extension. So remember to do that when you're naming your file. I'm just gonna fix that real quick. Okay, now that my file is actually named helloc.c, we can try to compile it. And we will do so through the use of GCC, which is the standard C compiler. And we will do so with the use of a couple of flags. Flags are certain commands, you could call them, which tell the compiler how to behave. The first flag we will use is -wall, which will display any compiler errors. Next, we will use -ANSI to specify we're using the ANSI format. Then we can use /pedantic errors, which is another flag, which will give us more detailed and specific compiler errors for the ANSI format. Next, we can specify the -O flag, and the -O flag simply means that whatever we type after it is going to be the name of our file. So I will simply call it helloc. And after that, we have to specify the actual file we want to compile. So it will be helloc.c. If I press enter now, as you can see, no errors appeared, and we can type another command. So we can try and run our file now. We can do so, at least on Linux, by using --, and the name of our file. And if I run it now, as you can see, we printed out hello world, but there's some unexpected behavior happening, and that's actually because we're not printing out the new line character after the hello world statement. And we can fix that by going back to our file, and at the end of our hello world string, we have to use a \, which is an escape character specifier, which basically means that whatever character comes after it is supposed to be a command, kind of, rather than a string of text. And in our case, I will type N, for N stands for a new line character. And if you use \n, it will simply print out a new line, which will fix whatever we just saw in the console. If I save the file now, go back to the console, I have to compile the file again, but I don't have to type it all out again because I can simply press the up arrow twice. I compile the file again, no errors, and then I can run it again. And as you can see, now we're actually printing out a new line after hello world. Okay, so we've just written our first C program. So what we can do next is actually try and play with our own functions rather than just the main function. I'm going to delete this statement, and before our main function, we will try to define our own function, which is not the main function, which is always there by default. When defining a new function, we have to specify first its return type. In our case, let's say we're going to return an integer, just like our main function, and I will call my function compute. However, after our function, instead of putting a body of it with curly brackets, I will put a semicolon. And that's because I won't be actually defining that function here. I'm only declaring it, which means I'm telling the compiler that, hey, there is a function called compute, which I will tell you about in the future, basically, but I just want you to know that it's there so you can put some space in your memory for it. And we're doing that before the main function, or rather in front of it, so that we can define our compute function after the main, somewhere down below, wherever we want to. If we would not put it above, the compiler would produce an error, since we're using a function that it cannot even see because of how the main function works. For my compute function, I want two inputs, and I would like both of them to be integers. So I will specify two types, integer, integer, and I don't actually have to give names to those inputs because we're simply declaring the function, we're not even defining it yet. So this basically tells the compiler that it should put some space in memory for a function that takes two integers as inputs and produces one integer as an output. Now that our function is declared, I'm going to actually define it under the main function. So we will do the same thing again. integer, compute, but now we actually have to give names to our inputs. So I will name them integer num1 as well as integer num2. And this time after the function, I will not put a semicolon, but rather open a body of the function and start typing code in there. So what do I actually want my function to do? Well, I would like to make it take in two numbers as an input, add them together, and just return the result of that. So first, I will declare a new variable, which will be an integer variable. I will call it num3, and after that, I will set num3 with the assignment operator, which is equals, to be equal to num1 plus num2. So now our function takes two variable inputs, creates its own third variable, and then sets it to be the result of addition of both of those inputs. And if we want to actually return that value from the function now, we can use the return statement, telling it to return num3. And our function is basically done. Now it will take whatever two numbers you give it as inputs and give you back the result of adding them together. In C, you can use all sorts of operators. It doesn't just have to be addition. You can use a dash for subtraction. You can use slash for division, asterisk for multiplication, and so on. There is many operators. But for this example, I just want to add my numbers, so I will use the addition operator. And one thing you can do is actually, instead of having our function here, I could literally just put it in front of the main function, and then I would not need my function declaration at the start. However, that is not good practice and it should be avoided. So the good practice to do in C is actually declaring the function first, then going into your main function, and after that, actually defining your functions. So how do I actually call my function now? Well, first off, our function takes in two inputs, so we actually need something that we can put in there. For that reason, I will define two variables, which I will call a and b, of integer type, int a and b. And in C, you can actually just use comma to define multiple variables of the same type on a single line. You can also assign a value to them on the same line as well. If I would simply put equals 5, that would set b to be equal to 5 since the very beginning. But I don't want to do that. I want to do it on the next line, where I will set a to be 5 with the assignment operator and b to be 10. Don't forget semicolons. We will also need a third variable, which will be used to actually store the return of our function, which will be num3. So I would like to define a third variable, integer, let's call it c. However, I cannot actually do it over here, because in C, defining the variables is only possible before you start any actions, any commands, any operations, which means our definition of the C variable cannot be over here because we just assigned some values to A, we assigned some values to B. We've actually done something in our function, so it cannot be here anymore. We have to go back to the very top of the function and put the declaration at the top before anything else. And now to actually call our function, we can simply put in compute and then in brackets our inputs, which will be variables A and B. Don't forget the semicolon. And that's how you call a function and give it inputs. However, we also want to actually save the result of that function. So we can simply do that by specifying C equals our compute function, because this whole statement will be replaced with whatever the function returns. So basically, we're saying C equals num3, and that should be all fine. And now I actually want to see if my function works, so I will print a message to the console telling me the value of C. To do that, we can use the printf function just like we did before, printf, and in quotes. Now, what do we actually put in quotes? We can't just put any random letters in there because that's not what we want to do. We want to print our C variable. And for that purpose, we have to include a format specifier, which we can do so by typing % and then specifying the format which we want to display to our console. There is different letters, just like with the escape character, there's different letters meaning different things, but we want to use D, which stands for decimal numbers, since we just want to print a decimal number. After our string, we want to put a comma, and then we want to put C, which will be the variable put into our format specifier, %D, which basically means this statement will print our C variable. If you have multiple variables which you want to print, you would simply add more specifiers to your print function. Let's say we're going to add %D 2 more times, and let's print CBA. To do that, we can simply put a comma after C, put B, comma after that, and put A, and it's just as simple as that. Those variables will map one by one to our format specifiers from the string. So just to prove a point, we can actually still put a string in here. It doesn't just have to be format specifiers. So I will put that our C equals our B equals and our A equals. And like last time, at the end of our statement, we want to put an escape character, which is \n, to produce a new line after our print statement. So that's everything. That should be our function fully working. So let's test it. Go back to the console. We can now try to compile our file again. No errors, everything is working fine. Let's try to run it. And as you can see, we produced a result. C equals 15, B equals 10, and A equals 5. And that would be it for the first video. I hope you enjoyed it and see you around.